This program is designed to teach the theory of mechanisms through automata. However, you can just use it to teach the theory only. Here's a typical mechanical system, an input, a control and output. Click on the image and you'll get a movie to explain.
This music box is a good example of a mechanical system. The input is the handle, the control is the worm gear turning the drum, and the output is the tune forks. The feedback is the...
There are a lot of images and text to explain the theory of many aspects of mechanisms. There are 4 types of main movement, reciprocating being one. Movies to explain all 4.
Reciprocating movement, that's a straight line back and forth movement. The needle on this sewing machine is a good example of reciprocating movement.
It's important your students find the right input to get the desired output. This is one of 4 screens. Click on the images on the right and get a movie to explain.
Because we have a crossover in the drive belt, we can change the direction. The input is going anti-clockwise, the output pulley is going clockwise. You can also see there's a ratio.
Click on the text on the left and it will take you to that part of the program. It's really important that your students know what mechanisms are available to them when they make their automata. This is one of about 8 screens. The middle image of the diagram shows how your students should design it. The automata down the right will show where that mechanism is being used.
The distance from the centre of your disc will determine the amount of movement you achieve. This one has the shaft hole on the outside, achieving quite a long movement. See how it moves the head.
This particular mechanism creates oscillating movement. It uses 2 eccentric cams.
To create an oscillating movement, 2 eccentric cams are being used. You can see the pins that are actually stopping at certain points. The effect we're getting from this is a head that's nodding and saying no.
Here we have a concentric cam that turns rotary movement around 90 degrees. This automata will explain to the student. In this case, the ball on the right hand side is using that mechanism.
A large eccentric cam to create all that up and down movement of the ball. Then we've got an eccentric cam.
Here we have the snail cam. Again, you can see automata where a snail cam is being used.
The automata of the devil hopping at the top of a cockpit uses a snail cam to create that snap action.
In this case, we're using a crank. This crank uses piano wire. It's a really excellent mechanism.
This crank made of 2 discs uses a plastic tube with a collar. Piano wire is also used, so you can actually change the direction from the input to the output. You can see here how the arrow...
Here we have one on gears, which will explain that. An eccentric cam, which acts as a pulley. Simple pulley system. Shafts are really important. Get the shaft in the right position. You might want 1 or 2 shafts. This particular shaft is using a pulley system to transfer movement from one to the other. Here a collar. Now the collar is really important. A follower. This will show how linkage and levers work. This screen shows simple levers and linkages. Click on the image and you'll get a short movie. This screen shows some excellent web links. Don't allow your students to waste time on the internet. Use these links, great for researching automata and mechanisms. There's some fantastic YouTube links. This particular one will show your students how an engine works. It's a fantastic resource. The homework section will check your students' knowledge, see how they're getting on. There's a section of results as well. Keywords are really important. Click on the keyword and find out more about it. In this case we have a worm gear. See how you can get a really long ratio between the 2.
This worm gear has a ratio of 25 to 1. 25 turns the input, which is 1 revolution of the output. This is full mechanical advantage.
Hope you found this interesting. Teaching mechanisms can be quite dry. This program will really help.